This is Module 1, Review 1, questions 9 through 12. On problems 9 through 11, it says complete the proofs below by filling in the missing statements or reasons. Remember to mark your diagrams. Points will be deducted if not done. Alright, so we do that anyway just because it helps us solve the proof. At least I always do. That's the first thing I always do is mark up the pictures. So let's look at number 9 and then we'll go ahead and mark the picture up. We have given LM is congruent to LO, so that would be this side over here and this side. Then we have MN is congruent to ON, so these two. And then we're trying to prove that the two triangles LMN and LON are congruent. So looking at the picture, can we match up anything else? And we can. We see we have a shared side right here. So just by looking for the pattern on the picture, I can see it's going to be SSS. Alright, so let's go ahead and fill out the proof then. LM is congruent to LO because that was given. Same thing with MN and ON. Then we have LN is congruent to itself. That's because of the reflexive property. And then we had the triangle congruence statement. LMN is congruent to LON because of SSS. Okay, number 10. We're given PQ is congruent to QS. This side and this side. We have TQ is congruent to QR, so this side and this side. And we're trying to prove that the two triangles PQT and SQR are congruent. And looking at the picture, I have a vertical angle in the middle, and then the pattern I can see is going to be SAS. So we have PQ is congruent to QS, that's given. We have another reason without a statement, it says given, so the other given is that TQ is congruent to QR. Then we have PQT is congruent to RQS, that's our vertical angle. And then we have our triangle congruence statement, which we figured out from the picture was SAS. Questions. Okay, number 6, they left off a couple of the angles over here. We had Q and R right there. Okay, so we're given that QS is parallel to RT. So QS is parallel to RT. Anytime we're doing triangle congruence and you have parallel sides, you want to look for corresponding angles, alternate interior angles, things like that we can match up. And then we had that R is congruent to S, so these two angles are congruent. I know they look like 90-degree angles, but remember, you can't go by the picture, you have to go by what they say in the proof. Alright, so we're trying to prove that triangle QST is congruent to triangle TRQ. We have a shared side right here. And let's see, we need to do we need a little bit more. And let's look at angle 1 and angle 2. If we look at those two angles, those are congruent because of the parallel lines and QT being a transversal. It makes those alternate interior. And then we need 2 of these because we already used 1. So we have, let's see, the pattern we have is going to be angle, side. Or some people write it the other way, side angle, angle. It doesn't matter, either way is good. Alright, so QS is parallel to RT, that was given. R is congruent to S, that was also given. Angle 1 is congruent to angle 2. Those are our alternate interior angles. So alternate interior angles. And then QT is congruent to QT, that's the reflexive property. Then our triangle congruence pattern we found was angle, angle, side. Okay, last question, number 12 says fill in all the blanks. There are 9. So there's 8 over here, and then there's this one right here. So we need to remember to do that last one. Alright, so what we're doing for this one is we're trying to figure out where the different vertices of this shape are going when we do all these different rigid motions. So the first rigid motion is a reflection in the vertical line of symmetry. So the vertical line of symmetry is a vertical line that splits it into, well, it makes it symmetrical. So we're going to go right down the middle like that, and we're going to reflect around that, or across that, and that means that A and the B are going to switch, and then the C and the D are going to switch. So we end up with this. And for the next part, we have rigid motion 2, which is reflection in the horizontal line of symmetry. So that's going to be this one. That means the B and the C are going to switch, and then the A and the D are going to switch. Okay, and the last rigid motion we had to figure out from the picture. So we're going from this shape, number 1, to number 2. And how do we do that? So it looks like what's happened was the A and the C switched and the B and the D switched. And we could, we could undo what we just did, because this is the same as this. But it says one rigid motion, or it doesn't say rigid motions, it says rigid motion. So we're going to have to figure out a different way. And it looks like for this one, if I do a rotation, if I rotate it 180 degrees, I can make that happen. So we're going to do 180 degree rotation around the center of the shape. So the center of